So in this video, we're going to look at rearranging equations, basically solving equations for different variables based on the information we've got, based on the information we're looking for, kind of figuring out what is the benefit to that. So we're going to look at three different things here, why we might want to rearrange an equation. First one is that it's going to make it easier for us to see relationships between different variables. What do I mean by that? What I mean is, well, if we increase vi, there's one variable over here, and delta x and a stay the exact same, what is going to happen to vf? How is vf going to change if that one variable also changes? Now, you might think, well, why do we need to know that? Well, it's going to allow us to see kind of what type of relationship there is between the two. Is there a linear relationship as one increases? Does one go up, one go down based on their mathematical relationship? It's going to help us see that a little bit easier if we isolate one of those two variables. We're also going to make fewer mistakes after we substitute in values when we start putting numbers in. Typically we'll have fewer mistakes that way, and we'll also have a new equation that we can have that we'll be able to use if we're solving for similar information later on. So for instance, let's go through and actually isolate for VF. So that way we can see what happens to VF if we change one of the other variables. So what will we do first? Well, the first thing we'd want to do is multiply by 2a, okay, to both sides. So times 2a. And that's going to allow me to get this off of here. And now I'm going to have the equation 2a delta x equals vf squared minus vi squared. Okay, we've gotten close to isolating for one variable. We just need to get vf by itself. So to do that, we're going to add vi squared to both sides. And that's going to get rid of this and this. And now we have the equation vi squared plus 2a delta x equals vf squared. And then we haven't fully solved for vf yet because vf is still squared. So we can go through and to undo a square, we take the square root of both sides. And we end up with an equation at the end of vf equals the square root of vi squared plus 2a delta x. Still not exactly, might be a little tricky to see what the actual relationship is, but we do know that as anything underneath this bracket, this radical changes, it's going to be based on a square root value effect on vf. So it's not going to be a linear relationship. We can see that right now. So that kind of pulled that out for us. So what you're going to be doing is practicing yourself. So there's a problem for you to practice right now. And here's that practice problem, just in case you were wondering how to get to it if you didn't get it right. Solving for a, and vf equals vi plus at. Okay, solving for a, the first step would be to subtract vi. So vf minus vi equals at. And then we would divide by t on both sides. And a is going to equal vf minus vi divided by t. Here's our other practice problem. Okay, we isolating for t and delta x equals at squared over 2. Okay, so here we have delta x equals at squared over 2. We're going to multiply both sides by 2. Okay, now get rid of this. So then we have 2 delta x equals at squared. We divide both sides by a. That gets rid of this a. So that tells me t squared equals 2 delta x over a. And then we have to take the square root of both sides. So t is going to be the square root of 2 delta x over a. Again, if you're having any issues with these, please reach out. Please let me know. Otherwise, you do have a couple more practice problems in the end, just to give yourself a little bit of a warm-up for the whole thing. And if there's any questions, please don't hesitate to reach out.